Exponents Part 2, taking it a little bit deeper. In Part 2, we're going to look at how some of the rules apply to some of the deeper problems, the more, not harder, just a little more involved. First of all, you see what appears to be, let me rewrite this, I don't like the way that looks. You see what appears to be basically the same exponent, the same expression written, well, twice in slightly different ways. And that is kind of true. Negative 6 parentheses to the fourth power. Okay, I said this was going to be a little deeper, and it is. So hang on while I try to explain this in a way that makes sense. Okay. The difference between the two problems is the problem on the top has the base inside of a parentheses. The problem in the bottom doesn't have a parentheses. We treat these slightly different. Okay, in the top problem, get rid of the arrowheads, we don't need them right now, so that was just for illustration purposes. In the top problem, what happens is that the exponent applies to negative 6. So it's negative 6 once, negative 6 twice, negative 6 3 times, and negative 6 the fourth time, all multiplied together. In the bottom equation, you have a negative sign that just kind of sits there and doesn't really attach itself to anything. Bear with me. So that negative sign sits there, and you have 6 times 6 times 6 times 6. In the top equation, we count up the number of negative signs we have. We have 4. 4 is an even number, so the answer is going to be positive. Now normally you wouldn't represent a positive number with a positive sign, but just for the sake of this explanation, we'll do it. Now when you take 6 times 6, multiply that together, you get 36. Multiply that times 6 and you get, let's see, 6 times 6 is 36. 6 times 3 is 18, 19, 20, 21, 216. And you multiply that times negative 6, you get 1296. And again, the answer is positive because we have an even number of negative signs. But look at the difference down here in the bottom equation. What you have is a negative sign that kind of is a standalone, and then you have all this math in here that's also a standalone. So in a sense, it's kind of like saying negative times 6 to the fourth power. So then you have 1, 2, 3, 4 positive numbers, which you will end up with 1,296 times negative, or you can think of it as just bringing the negative sign down. A little bit confusing, but if you look at it for a minute, you'll realize something. You'll realize that the negative sign, this negative sign, and this 6 to the fourth power are just being treated like two separate entities, two separate deals. This is one deal, the negative, and the 6 to the fourth power is another deal. Okay, as opposed to this top one, this negative 6 being multiplied out 4 times because this is grouped together inside these grouping symbols. The negative is included. I guess one way to say it would be the negative is included here, but the negative is excluded here. Then we have the case of the negative exponent. Not very difficult at all, really. It goes like this. Anytime you see a negative exponent, first thing you do is draw a fraction bar and hang a 1 on the top. Then you take all of this, except the negative sign, and you put it down below, 2 to the third. So by sort of taking the reciprocal, that means flip-flopping it, numerator, denominator, we eliminate the negative sign, which is what we want, and the answer is 1 over 2 to the third power. So again, with a negative exponent, you draw a fraction bar, hang a 1 upstairs, take the exponent without the minus sign on the exponent, bring it down in the denominator, and your answer is 1 over 2 to the third power. But then you might say, but Mr. Deal, what happens when the base is negative and the exponent is negative? Haha, fret not, my math genius. In training, I will show you the way. First of all, if you remember what we said a minute ago, we have a negative exponent, right? So the first thing I'm going to immediately do is to draw a fraction bar with a 1 in the numerator, 1 upstairs. Okay? Now, in the denominator, I'm gonna write everything except the minus sign, and I'm going to place it in the denominator. So I'm going to exclude this guy. Negative 3 to the 5th power. See, it's pretty much the same thing. The only thing is, this didn't have a negative here, it's positive. So negative 3 to the negative 5th power is 1 over negative 3 to the 5th power. So then you ask yourself, or you say, Mr. Deal, what is 1 over negative 3 to the 5th power? To which I reply, dude, you're asking too many questions. Just kidding. Okay, let's map it out. Let's clear a little space. Let's get rid of this. Yeah, I'm not going to erase the whole thing. Just as much space as I need. I don't want to spend the whole rest of the video just drawing and erasing, you know? Because what good would that do either one of us? Not much. Okay, let's go back here, and we've got 1, I'm going to draw the fancy one, over negative 3 to the 5th power. So that means negative 3 once, negative 3 twice, negative 3 3 times, negative 3 4 times, and negative 3 5 times, right? And what does that give us? Well, it gives us some big old number. Who knows? I don't know yet. 1 over, now let's figure out, first of all, just to not get ourselves all hung up with the, the stuff, the signs. Let's just count up the signs. We've got 1, 2, 3, 4, 5 negative signs. 5 is an odd number. Therefore, the answer will be negative. And now we've got 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 27 times 3 is 7 times 3 is 21. 2 times 3 is 6 and 2 is 8, 81, if I did it right. I hope I did. And then 81 times 3 is 243. So 1 over negative 243. In the part 1 video, we said when we multiply exponents that have the same bases, what we do is to add the exponents. But look, we've got a negative number in our exponent. Whatever will we do? Well, let's see whatever we will do. The base is 3, so we're going to put a 3 here, right? Base is 3, so we're going to put a 3. Let's get rid of these guys. You took a piece out of that 3. Too bad. Okay, now we have to add the exponents, right? So we have negative 9 plus a positive 7, which is the same as saying negative 9 plus 7. And if you remember your rules for signs for addition and subtraction, if the signs are opposite, which they are, we have a negative and a positive. The signs are opposite, we subtract the numbers. 9 minus 7 is 2. And the answer takes the sign of the higher number, which is negative. So we have a 3 to the negative 2 power. But look again. If you remember what we said about negative exponents, what we're going to do is take that 3 over negative 2, I'm going to write in this space right here, and we're going to draw a fraction bar, hang a number 1 in the numerator, and put everything except the negative sign down in the denominator. 3 squared. And if we want to take it a step further, we would call it 1 over 9. By the same token, if you recall the steps for dividing exponents with a common base, with the same base, we know that in the answer the base is going to be 4. But since we're dividing, we have to subtract the exponents. So our exponents are 2 and negative 3. And what that's going to look like is, negative 2 minus 3. So it's going to be negative 2. We subtract because we're dividing. And the other exponent is negative 3. And of course you recall that when you have two negatives, that borrows from the rules for multiplication for signs. This becomes negative 2. A double negative becomes a positive plus 3. And taking from the rules of signs, when the signs are opposite, which they are, you have negative and positive. You subtract the numbers, which is 1. The answer takes the sign of the larger number. The larger number happens to be positive. So it's 4 to the first power, or just simply 4. If some of this is a little confusing on the first pass, the beauty of having it on video is that you can run it back a couple of times, listen to the rules for the different operations, and just watch how it plays out. You may not get it the first time, and that's okay. That's why they call it learning. Sometimes things take a few more observations to learn than other things do. And that certainly is possible in the case of all these rules of exponents. I was going to say exponential rules, but that didn't sound right. So just watch the video a couple of times, and of course, ask questions if you have them. Make a note, bring them to class. Okay, so that's the end of part 2 of exponents. And not a moment too soon, right? See you next time.